First of all, a very good morning to one and all present here. Myself, Pooja Chakraborty, Assistant Professor of CSA Department, thrilled to express my warm invitation for the International Short Term Training Program in Machine Learning and Data Science Marvels. As we are on our fourth day and first session, for today's session, our chairperson will be Mr. Shiv Prasad Sir, Assistant Professor of IT Department. This session promises you all to be an enriching experience, offering a valuable insights, thoughts, and knowledges in the dynamic field of machine learning and data science. It's my pleasure and honor to introduce our esteemed resource person, Dr. Oritam Bishwas Sir, Associate Professor and Head of the Department of CSA Department in Kazi Nazrul University. For today's session, Sir will be addressing our event as a distinguished speaker. I would be happy to announce that Sir has an outstanding portfolio comprising as a total of 110 publications as a total. At present, Sir is working as an assistant professor of CSE department in Kazi Nazrul University. Sir has already worked with Asansol College and so on. Sir has already completed his BTech degree from MACAUT and thereafter MTech from Calcutta University and then PhD from National Institute of Technology, Durgapur. Sir has a keen interest for research in machine learning. Sir has recovered several honors and awards like Young Engineers Award, Institute of Engineers, and specially appointed Associate Professor for Research Institute, Electronics, Japan. Sir has also guided so many doctoral theses. And now, Sir has different membership in professional bodies like Institute of Engineers, Optical Society of India, and so on. Therefore, I request to all the participants to stay with us and welcome, sir. We are keenly waiting to hear from your lecture today. Please take over the session, sir. Thank you so much.
Thank you, Dr. Chakraborty, for the introduction. I think there is very less number of participants, including me, four. So can I start now, Dr. Madhu? Okay. Okay. My slides are visible.
Yes, sir. Your slides are visible.
Okay, today we will discuss about the digital mining towards the industry 4.0, mine safety and productivity. What is the digital mining? Digital mining means application of IoT, AI, deep learning, machine learning in the towards the digital transformation of the mining industry and which relates to the industry 4.0. Now the chief operating officer and two mining companies they quote that if we don't change the business of mining we won't have a mining business. So we need to change the mining environment. We need to change work towards the industry 4.0, and we need to introduce the application of machine learning, AI, IoT in the mining industry. Now, what is Industry 4.0? The industry, it is the revolution of in digital transformation of the any hardware industry, and in Industry 1.0 mechanization and the induction of steam of and water power. In Industry 2.0 mass production assembly lines using the electrical power, and Industry 3.0 automated production, computers, IT systems, and robots. Now in Industry 4.0, we are looking for the smart factory, autonomous systems, IoT, machine learning, etc. Now timeline into 2023 investment of boom in mining driven largely by demand by the from China, then the lower commodity prices and mainly record of the Australian coal and mineral production. Now the in 2016 to now of this the accelerated investment in digital technologies. The industry leaders BSP, forecasting mining groups, Northparks, etc. This is now mining industry investing on the digital transformation of the mining industry. Presently, I will send the details. Presently, Coal India investing near about 500 crores for giving the project to the Central Institute, United State Universities, for work on transformation of mining industry using IoT, AI, and machine learning. Now, the global market for Industry 4.0, the Internet of Things, this is the global market. The exponentially, this is the billions of devices. Years, this exponentially increases. Now, types of automation, there may be basically the two type of automation: equipment automation and business process automation. And the equipment automations both are increases. Both type of automation, equipment automations and business process automation, will increase the productivity, designed to take people out of the control loop. Both can enhance the mine safety, and project implemented risks need to be carefully considered for technology investment. In Industry 4.0, there include very wearable devices. Suppose this is a wearable jacket where we introduce the activity sensor, GPS antenna to locate the manpower and the external temperature, and the communicative antenna, electric box, activity sensor in different places of the jacket. This is introduced for the safety and productivity of the mining industry. And one is this type of heads-up cap. The smart cap maybe help is the driver's fears of drowsiness. In the mining industry, we know that there is a different kind of vehicles, and we have to take care. The driver should be taken care of the vehicles. If they have a drowsiness, then accident maybe happen. So the smart cap recently used using for the driver's fear of drowsiness. If there is a drowsiness, then alarm will be on. Now, what in the, for mining industry 4.0 is integrated in an intelligent mining, and it is there is a mainly four layer. Number one is the control layer, then model layer, then sensing layer, then execution layer. In control layer, based on the feedback forward and feedback control. Then model layer, there's a different kind of model. Ore body model may be there, feedback discuss model may be there, bus model and design there, and process model will be there, trend dispatch and stock years model will be there. Then based on that model, the sensing is required for IoT devices or smart mining. Then in sensing layer, geophysics and drill sampling, measurement drilling, hyperspectral sensing, online grade or quality sensing, metallurgical yield or coal quality, and online grade sensing. This is the related to sensing layer. After sensing the sensing from control layer through model layer. Through model layer using the feedback and forward and feedback control, ultimately it goes to the execution layer. In execution layer, there is the material composition tracking. Ore body is there, drill and blast, load and hole, and stroke line and class, mill, and CHPP to train load out, rail and port rock yard. So those are the execution layer. We have to execute those industry 4.0 machine learning in those execution layer. Now, opportunity one, feed. At first, we have told already control layer based on the feedback control. So, from where it is taken the feedback, suppose the feed forward, example, the plant optimization. In case of plant optimizations, drill bus layer, load and haul, and stock and class, it should be taken from here, and the harshness and wash characteristics. Then it is goes to the process control, and also taken input. There's both set of input from mill and CIPP train layout, and ultimately it goes to the process control, and after the process control, it goes to the execution layer. Similarly, opportunity feedback. Opportunity one will be the feed forward, and opportunity two is the feedback. In case of feedback, also the deal busting layer going through the blast model and design. Then the load and haul should be come across this great quality and blast design, and this is harshness and work statistics, and ultimately it goes to the ore body model, and this is the rapid resource reclination. And what happens to this data, and the several steps is there, how digital innovations can improve the mining productivity, and that in mining company only use the function and have their data, the operational information is there. There is a several failure points, then data not captured, then if data not captured it come this way, then data captured, if data not captured they come this way. This is then infrastructure, then data management, and during the data management there is data not accessible. Then during the analysis and automation, data not analyzed data is come here, then analyzed and automations, then data not communicated is come this way, and after that visualizations, and after visualization some data is used for the design making, and whose data not used for design making will come this way. So this is the mining companies use only the function and fraction of their data, and this volume data ultimately execution level is near about or less than 1% data may be executed. Then the value case, the value of the stack for mining industry is sizable, and it is a several layer. First one is operational management, then equipment maintenance, then health and safety, then equipment supply, then human productivity. And in case of operational management, deeper understandings of the resource-based optimization, materials equipment flow, increase the mechanism through the automations, monitoring of real performance plan, then improve the anticipation of failure, then reduce the unscheduled breakdowns, and for health and safety, minimize the exposures and dangerous control, then equipment supply, improve the purchasing analytics, internet of things, enables R&D, and then the human productivity, augmented reality and task-based activity monitoring. So those are the applications and their descriptions, and you know the potential economic impact of the application in 2025 is billion annually, and this is the potential economic impact of the sized application 2025. Now, products value and trends mining. This also support activities is there, and in there is a margins, and in the primary activities we know the mineral exploration, ore body modeling, planning and construction, supply chain, inbound, outbound, mining operations, and mining processing. This marketing and sales. This is the primary activities, and then engineering, technology, and maintenance, then procurement, stores, then environmental management, and ultimately it is goes to the human resource, finance, and business planning. This is the maturity scale. Motivations is there, avoid breakdowns. I think this is a business project, artificial intelligence. Uh, Now we discussed that we have developed the environmental monitoring and underground mines using sensor-enabled Internet of Things. This project is going on in our laboratory. What is the approved objective of this project? Development of an environmental monitoring system for underground mines, which can effectively measure the real-time status of hazard gas emissions, temperature, humidity. You know, in underground mines there are different type of hazard. Methane gas may be increased. If methane gas is increased, then explosion is there. If temperature increase, humidity is increased, that increase the methane gas. So we have to control those underground hazard through the IoT based system. Then our second objective was approved to develop the miners equipment tracking systems which give the precise alarm and development the alarming system that intimating the miners in case of emergency and unsafe environment condition and in mining practices. So this is the approved objective for the said project funded by DST. So for that purpose, we have to understand the fire map exploration. What is fire map exploration? That term, you know, these are the mines, these are degrees of gas, and number of accidents, and this is the reason, and this is the date of accident. So for this information is came out from the in DGMS in 2004. There is a Nadir Khan Coast Colliery. There are about 20 accidents is there in 1908, and all are accidents due to the fire dam exploration. What do you mean fire dam exploration? Fire dam exploration means if the exploration due to the methane gas. We know that in the fire dam explosion due to the gas mixtures, and in the methane there is a CH4. If it is coming to the oxide, then there is a fire dam, and this is the fire dam graph. This is the explosive region of methane gas in underground mines. This is the near about 5.5 to 15, 14.8 better to say. Within this region, if the methane gas is there, then there is a chance of huge exploration and a chance of the accident. So below the 5.5 and up the 14.8, there is no chance there are no exploration. So we have to maintain the methane gas in between this. For that purpose, we have developed a resistive type methane gas concentration transmitting using SNO2 materials. In this case, we know SNO2. In this case, the SNO2 layer is used as sensing materials. We will later on slides we will discuss and we will show how these sensing materials works. And this is the SNO2 materials. This SNO2 materials is used as a sensing materials, and that if the methane gas decreases, the electrical resistance with the increase of the methane concentration. So that SNO2 layers is developed by through this project. Then the Western bridge is
Excuse me, sir. Your voice is not
So
audible.
this is the methane concentration and measurement. We have developed these systems in our laboratory. So this is the sensing unit, methane gas sense, then Western bridge, then analog amplifier, then signal controlling unit, then microcontroller, and a publisher, ultimately cloud and subscriber. And this sensing unit we have developed. This is the methane gas inlet. When the methane gas inlet is there is the anti-explosion net. Then there is the fan for go through the methane gas from this inlet to outlet, and this is the heating unit. This methane gas heat this unit. Then the sensing element SNO2 layer is there. Ultimate methane gas outlet, and based on this sensing unit, we have this sensing unit. Output of this sensing unit is go to the Western bridge circuit. In Western bridge circuit, if the methane gas increases, the resistance decreases. That resistance will be converted ultimately to the voltage. Now, for development of IoT and ML-based methane gas monitoring, we have used ESP32 node-based and MCU is utilized for the study. Sensor configuration, we have used the SNO2 based methane gas sensor and DT DAST11 sensor. This is basically the humidity and temperature sensor that is used in mines. This is the commercially available. And data storage, we have used the Amazon AWS cloud services are employed for data collection, storage, analysis, and gather data. Then IoT cloud platform. This is the one convenient IoT cloud platform is used, and this IoT cloud platform is this is the free for the academic users. We used those IoT cloud platform. Then forecasting model, we have used basically LSTM based forecasting model. This is and hosted on the AWS cloud is implemented the prediction the methane gas values, and this forecasting model predicts value up to 8 hours ahead. So this is the visualization comprehensive data flow framework. So this is our IoT enabled. This is our IoT enabled capturing and visualizing methane gas data. This is that I already told. We have used the one commercially available unit. This DS commercially available temperature and humidity sensor. This is that. This is that sensor. This is the alarming unit, and within that, this is the sensing unit, and this is the display. And this is connected to the through the Wi-Fi router to the internet. And AWS cloud is used for the data analysis by help of the LSTM model, and the convey Canny cloud. This is the cloud available free for the IoT academic purpose IoT devices. And then the mobile application of web-based dashboard visualize the real-time and forecasted methane gas data. So this is the schematic diagram of the IoT device. This device is this is already discussed the function of this sensing unit, and this is the methane gas sensor is replaced here. This is the temperature and humidity sensor. This is the module ESP32 modules. This is the buzzers and LED, and this is the compact model of our device. It is shown clearly the methane gas ppm, the percentage of the methane gas within the mines. This is the laboratory setup for sensor calibration and IoT devices testing. We have already told, and this is the gas chamber we have developed through this DST project, and this is the methane gas testing chamber, and this is the IoT devices we have already discussed. This is the flowchart of IoT and ML-based methane gas monitoring, forecasting, monitoring, and warning system. It start, then initialize the system, then the sensor data received by the IoT devices, then data sent to the AWS cloud and Canny cloud using the MQTT protocol. Then it comes down. Then forecasting done by LSTM model. That deployed in AWS. That LSTM model is deployed in AWS already, and then forecasting. There is any problem for slide changing?
No, sir, your slide is completely visible.
Someone is SMS slide is not changing. AWS cloud, then forecasting value of the methane gas concentration threshold. If yes, then buzzer is there. If no, it comes to that way. And then forecasting done by the LSTM model. Then the forecasting data sent to the this IoT cloud. Then the real time monitoring, and after this real time monitoring, it goes to the send the SMS and email alert the mine management, and then the continuous briefings buzzers. Then methane gas concentration come for this from this side. So this is the complete flowchart of IoT and ML based monitoring system which we have developed in our laboratory through this DST project. Now this is the output window of this forecasting model. The output window of this forecasting model, and this is the mean average error in ppm. This is the there is equals versus mean average error, and the acquired forecasted model value of this system is nearly same. And this is based on the those forecasting based on the LSTM model. This LSTM model is long short term memory network. And this is a comparative result and other comparative result with the other methods. This LSTM location 1, 2, 3, and this our device is installed in Bankola area mines in different location. So this is the location 1, 2, 3, and this is the, we have tested with LSTM, MLP, and VAR, and we have shown that, and this is the comparative result of our method. And this is the you show this is the LSTM model, the methane gas within the range. And this is the snapshot of that IoT dashboard and Android applications. We can show the methane gas concentration over here. And related to this work funded by Department of Science and Technology, Government of India, we have made those publications based on this work. Based on this work which we have discussed for monitoring the methane gas in underground mines through IoT and machine learning based approach. Conclusion, over next 5 years, we will see the great change in digital connectivity and intelligence via Industry 4.0 technologies being adopted and developed for mining. Human also instrumented via wearable technology, and this will enhance safety, financial, and environmental and social performance of the mining industry. And we have to acknowledge for this project, and the project is funded for this talk. Our project is funded by Department of Science and Technology, Government of India, for develop the environmental monitoring system in underground mines. And we are I am working as a lead principal investigator along with me. Two mining engineers is there, Sanjay Gorin and Somodip Pati, and some collaborator from Japan, Singapore, Malaysia, and Professor Chakraborty. Thanks for your comprehension. This is over from my side.
Thank you so much, sir, for your time. So, as our chairperson is Shiv Prasad, sir, so I would like to inform, sir, please say something about our Arindam, sir. Okay, so as I can see, Shiv Prasad sir, that is our chairperson, having some issues with the network. That's why he can't able to conclude. So I'm concluding on behalf of him. Thank you so much, sir, for your time. We have already gained different types of knowledge on this domain. Thank you so much for your time, sir. And as I can see from the YouTube chat box, there is no such questions from the students. I hope they have already enjoyed the session and they have learned something from you.
Thank you so much. So I am leaving the session. Hope we'll meet physically next time.
Yes, sir. Sure, sure. Definitely, we will meet again. We will again try to arrange some international STTP program. Thank you so much, sir.